Welcome back to the Trading Cryptocurrency with Python series. In the last couple videos, we've been looking at Bollinger Bands and trying to develop some trading strategies around those. In this video, we'll be looking at a variety of other technical indicators we can use, and just to kind of give an idea of what else is out there, what tools are available in developing your own trading strategies. We'll actually be using principal component analysis to kind of cluster some other technical indicators and see if we can kind of find some pockets of positive buy signals that we can develop later into a trading strategy. This will be the last video where we're kind of developing strategies, and in the next video I hope to move on to actually implementing them. I just thought this would be a good way to kind of show what other indicators are out there and what other tools you have available that you can use in creating these strategies yourself. So let's jump into it. I have a notebook opened here just with some preliminary things. We already went over how to gather data from the Binance API. In this video, I want to use a variety of different cryptocurrencies other than just Bitcoin, Ethereum, and Litecoin as we've been using in the past videos. So I've already got this written up just to save time. If you haven't seen part 1 of the series, I'd recommend going back to that one first, and that's where we've covered, gathering data from the Binance API. The only difference here in how we're doing this is instead of merging each cryptocurrency data frame together, we're actually writing them out to CSVs individually here, just because we have, a lot more cryptocurrencies available to us in this one. So I have the script here. It takes a while to run, so I've actually already run this, but basically we're just writing these out to CSV files. Within the working directory here, I've just created this folder called data, and I've written out data from January 1st of 2017 all the way up until now. So that's these files inside this data folder. So you can just create a folder called data inside your working directory and run this script here, and it should generate these different files. And so we'll have to do some pre-processing just because we're reading CSV files out of this. So what I've done here is just listed the path to this. This is just, you can grab this by just clicking on this data folder and copying the path there. The double backslashes are just escape characters, so Python can read the file name properly or the data path properly. And then obviously our list of symbols here. These are all the different cryptocurrencies we'll be looking at in this video, and then this variable here, file names, is just a list of this directory. So if we run this os.listdir function and put in that raw data path, run this first. I should actually just break out of this so we don't have to do this every time. So we'll just run it for one first, and then you can see, we've defined this raw data path, and we can list out all of the files in that directory. So moving into some of the pre-processing we have to do, basically we're just reading this file from the CSV. So this path here inside this F string is just going to be, the first data path and we'll iterate through these to read all of the data in that we need. So if we just set file be the first file name, file names I believe it was, you can see this is the path we're reading as we iterate through this for loop. After we read in that data frame, we're going to grab the symbol of that respective file that we just read in. And so what this will do is, from this file here, this file string is the first file here. We're going to split it on these underscores. This string.split method will basically just take all the underscores and make this a list. So you can see here what this does, and then so basically all the underscores removed and everything in between made into a list. And then we'll just be grabbing the first index of that, or the 0th index of that, so that we can read in our symbol. And the last thing that I have written up here prior to starting the video is just converting those date times. Since they were in a CSV file, we're reading them back out as strings, and we've done this once before in a prior video. So this is just, converting all of those date times and then writing them back to their columns for the open time and close time. And so in this video, kind of what we'll be doing first is we've already gathered and converted the data. The next thing will be generating a label for each data point. We're going to add some technical analysis features and then normalize and concatenate all those cryptocurrencies together. And then finally, we're going to fit a principal component analysis model, which we'll get into later. But first, we will generate a label for this. So you can see, we'll just work on this first data frame here. The first one is ADA, or Cardano. So you can see what we have for this. This is the same as when we initially gathered data in part 1 of the series. This is everything that the Binance API spits out when you ask for historical clients. And so when I say generate a label, basically what we want to do is we want to, at each time point, we want to look X number of hours into the future and see what was the price movement, starting at time 0, what happened at time 4, what was the ratio there between these two prices. So as we want to iterate through this data frame, and so we can show that basically we can iterate through the index for I in range length data frame. This will iterate through the index here, and then we want to grab that open price. So we want to find the ratio between the open price of the first index or the current index, and then divide that or find the ratio between that and the close price of, we're going to use 4 hours, but that's sort of an arbitrary choice that can be tuned later on. And so to do this, let's create a variable called hours equals 4. This way we can change that later on if necessary. And we'll call the symbol. So we're going to use an F string here to grab this, the symbol of the data frame we're currently working with, and we're going to use the close price first of, so this column name is dash USD close, and then we want the index that we're on, with respect to the for loop. So we're going to use this .illc as index location. So we're going to grab the price at index location 4 in this case, or plus hours. So we define hours to be 4. So we're going to look ahead 4 hours, grab that close price, and we're going to divide that by the open price of our current index. We can also create a list called, we'll just say labels, and then we will just append, as we go through, we'll append this result to labels. And so we'll need to, I'll just do this within the main for loop since we're breaking out anyway. And so we have an index error here. And this is expected. So this is because we were looking ahead 4 hours. So once we got to the end of the data frame, basically we're looking further than the actual indexes. We come to the third to last index, and we ask for third to last plus 4. It's no longer in the data frame. So instead of going through the entire length, let's actually go through the length minus hours so that we don't hit that error. And what the result of this will be is in this labels list, we basically have the change in price at every time point with respect to the next 4 hours into the future. So a positive, or a number greater than 1 here means the price increased. In this case it was 3% increase. A number below 1 here indicates that the price decreased. So in this case it decreased by 2%. And then because we are not iterating through the whole data frame, this list is now 4 units shorter than our data frame is. So because we need to look into the future to get this, we can't use the last 4 indices. So we'll just chop that off of the data frame before we add the labels. A way you can do this, basically the df.head function. Oops, head. This will just give you however many rows you specify from the start of the data frame. So if we say 10, it'll give you the first 10. So we want all of them up to the 4th to last index. So we'll do length of data frame minus hours. And this will give us all the indices up until the 4th to last. And so we'll set that to our data frame variable, and then we'll put the label as a column in the data frame as well. So label, it's labels. And now this time we have our data frame with, at each time point, we have our label. Did it increase and by, or decrease, and by how much? And so the next thing we can do here, so this will be useful later on. This is sort of what we're trying to optimize for when we're trying to develop a strategy and trying to find those good buy signals. We're looking for the highest label possible, right? Because we want to buy at a time point at which the price increased shortly after in the future. So that is step 2 here, generating the labels. So now we'll move on to adding TA features. TA stands for technical analysis. We're going to use a library here called TA-lib. I already have it imported here, but I'll pull up the documentation. And so you can see this is just Python. I'll say that's not the Python one. So this is just a library you can use to generate a bunch of different technical analysis features. You can install it this way from the command line, or you can just do exclamation point within Jupyter and run this command here. I'm not going to do that since I already have it installed, and then you can, the specific function we'll be using is called add all TA features, so you can just import that like I have listed here. And so what this function does is it takes in the data that these columns here that I've highlighted, and it will compute a bunch of different technical analysis indicators for us. And so we'll do that here. Add all TA features for our data frame, and we'll need to pass the rest of the parameters too. So the open, you can see if you control or shift tab on this, you can see the parameters this takes in: open, high, low, close, and volume. So our open column is going to be, we'll just grab the column names here. Our open column is going to be USD open. And we're going to do that for our symbol of interest. We have close, high, low, volume. And we will, everything will start with the symbol we're after. We want to put that in the high parameter. Low, the close, and lastly the volume. Close that string. It looks like we have, we're missing our closing strings here. And so this function actually happens in place. What in place means is just that if you pass the data frame in, you don't actually have to assign it back like this. It's actually doing that in place. So if you run this function on df, it'll actually assign this back to data frame in place. And so if you see, our data frame is already assigned in that way. But you can see the result of this. We now have tons and tons of indicators here. We won't be using all of them. You can look in the documentation. It kind of details how all of them are calculated and what they're useful for and things like that. But you can see our column names now. We have quite a bit of indicators added to the data frame. And so I have a list of these that I've chosen already as sort of the ones that we're going to be using in this video. Basically, I went through these and tried to find ones that are on a normalized scale, so it's not, for example, in the past we used simple moving average. If the price 3 months ago was half the price of what it is now, that's not going to be useful information trading on an hourly basis. We don't really care that the price was 30,000 3 months ago if the price is 60,000 now in Bitcoin, for example. And so we want to find these normalized columns. So the ones we'll be using, I'll define here. These are these norm columns. Basically, these are all columns that are on some sort of normalized scale. Like for example, this RSI fluctuates between 0 and 100, and the others have their own relative scales that we'll be normalizing in a second here. And so this is something you can experiment with and kind of look into the other indicators, what they mean, and how you think those might be applicable into any given strategy. But so we'll add our features here, and then we will select our normed calls. So if you pass a list of column names in brackets here, this will just grab those specific columns you're interested in, and we'll pass that back to df. And so running this one more time. Looking back at our data frame, we have those columns that we selected. And now you see how these nans are in here. Basically, this is because a lot of these indicators require previous data points to compute, similar to the moving averages we were looking at in previous videos. And so the largest window here that any of these are using is 50. So we can fill NA here. There's a parameter. Parameter within this function, fill NA is true. If we run this again, those will just be filled with zeros basically. But then we're going to want to chop off those first 50 indices. And you can do that by just using a slice here, 50 colon, meaning 50 onto the end. And so we run this again. You can see we now have, starting at index 50, we have all the data we want, and everything was able to be computed at that point as it needed 50 prior values to compute them. We'll also reset the index of this. We want to drop previous, so drop equals true. That'll just reset it so that we're still starting at 0 instead of 50. So the next thing we want to do is some of these, even though they are values that are indicators that kind of bounce between specific ranges, we still want to normalize these so that they're all on the same scale. And so some are from 0 to 100, you can see, some are from 0 to 1. We just want to normalize this so that they're all from 0 to 1. And I think we can just find a chunk of code here from Stack Overflow. Yeah, so this is basically just min-max normalization. It's going to normalize everything from 0 to 1 based on the min and max of that column. And so we'll call this, we can just keep this as df. So we run this again, and we'll see that our values are all now some value between 0 and 1. So coming back to our guide here, we want to normalize all the values, and we're also going to want to concatenate or stack the results on top of each other for all the different cryptocurrencies. We're going to be analyzing these all at the same time using our principal component analysis model. And so as we iterate through this, we're going to want to list out these data frames and into, or append them into a list, and then concatenate them after the for loop is finished. So we'll make a list here, an empty list called x's, and another one called y's. So in terms of machine learning in general, and specifically for principal component analysis, x's are, or the x data frame is generally referred to for your feature set, and the y's is generally referred to for your target or your label. And so in our case, our x's are going to be, we actually didn't want to normalize the label here. So maybe let's do we shouldn't assign this back to the data frame variable just because we've already added the label, so then we just dropped it there. So instead, let's do something like this, and this will be df features, and then we can use df features here instead, because we don't want to normalize our label. We want to keep that as is. And we'll call this, we can call this x. So this is our feature set, and we will append x's dot append. So now we'll have a list of all of our feature sets for each cryptocurrency respectively. And then secondly, we will want to add our labels. So we can do df labels, and then y's dot append y. And so if we run this, we can see our x, label, not label, labels. And so now our x data frame is all of our features, all those indicators we generated, and our y is a series of all of those labels, or how much did the price increase or decrease. And so this time we'll remove this break statement, and we'll run the whole loop this time. And we can then, at the end of all this, we can concatenate, using pandas function concat, our x's and our y's. And we can call this x. Now that we're through the whole loop, so we can overwrite these variables. And we'll let this pre-process. And so the issue we have here is we define labels outside of the entire for loop. This should actually be a new empty list for each cryptocurrency data frame. So it shouldn't be outside. It should actually be before we start appending to it. So let's try that one more time. And let this pre-process. Okay, so now that that is done pre-processing, we can take a look at what we have for x. If you remember, initially, just for one cryptocurrency, we had 17,000 and change rows, and now we have all of those stacked on top of each other. So now we have just under 250,000 rows, all of the technical indicators every hour since January 1st, 2017, for all the cryptocurrencies in our list here. And so the next thing that we'll do is now that we have our feature set and our labels built, we will do some principal component analysis. The idea of principal component analysis, it's an unsupervised machine learning technique that takes in higher dimensional data. In our case, we have 11 features, so 11 dimensions of data here. And it tries to distill it down into the most meaningful, or the most the directions with the most information. There's a bit of math that goes into it. We're not going to get into the details of principal component analysis today, but that's kind of the idea. So we're going to use two principal components here. We're going to take 11 dimensions of data, and we're going to distill that down into just 2 columns so that we can plot this and kind of visualize what's going on here and then see that how it corresponds to our labels. And so it is an unsupervised method, so when we fit the model, we will not give it any information regarding our labels or the price changes. It'll be only looking at these features here, these 11 features. So we'll be using Scikit-Learn for this. Scikit-Learn, component analysis. And Scikit-Learn makes it very easy to actually use this in practice. There's kind of a lot going on under the hood that you don't necessarily need to know to actually use it. But it is, interesting. Maybe we'll do a video on it sometime in the future. So just copy and pasting from the documentation here. This first line just initializes the model. So if I comment this out for now and run this, we need to import this as well. Where was that? And if you don't have this installed, if you just pip install Scikit-Learn, that should work as well. So we can import PCA. This will build us just a general principal component analysis model. It hasn't been fit to anything yet. So for PCA, all we've told it is we want 2 principal components. We can then fit this to our feature set. So calling .fit and passing in our X data frame as our feature set. Now the PCA model that we have here is fit, but we still haven't done anything to X. We haven't actually predicted anything or transformed X. And so there's another method you call here, PCA.transform. And so like I said, this is, Scikit-Learn makes it very easy to use it. There's a lot more obviously going on when you call these functions. But you can see this returns a NumPy array. Let's just make this a data frame instead of a NumPy array so we can see it a bit better, and we'll give our column names of PCA1 and PCA2. And we will assign that to PCAs. So now if we look at this data frame, we can see instead of 11 dimensions of data, we just distilled it down into 2. Obviously, we do lose some information doing this, but this kind of gives you the most useful directions of the 11 dimensions we previously had. And so the next thing will be to add our label on. So again, up until now, the model has not seen the labels, and it won't. So we'll predict, or we generated these principal components, and now we'll just tag on the labels that we previously generated, which is our Y. This is a series, so we'll just make it a list when we assign it. And so the issue here was that we chopped off the 50 first entries for each of our features for our X data frame, but we didn't actually do this for our labels. So we have more labels than features right now, which obviously is not what we intended. We want the labels to correspond exactly to the time point that they were generated from. So a fix to this is we can actually just do this in a second step. So let's still call this df. So the label is still on this data frame, so we're cutting off the first 50 labels as well, as we intended. And then we can do this filter for normed calls. And we'll call this our df features. So I'll rerun this. Okay, so now that is done pre-processing again, we can refit our PCA model and assign the labels as we intended. And so now in this PCA's data frame, we have our 2 principal components and our label. And so the next step here is we're going to try to plot these and see if we can identify any clusters of principal components here that correlate well with a higher label or a profitable label. And so to do this, we'll use Plotly, have Plotly Express imported here, and so just use px.scatter and just do a scatter plot of PCAs, x equals PCA1, y equals PCA2. And so you can see here, now we have our principal components plotted on their x and y axes. And obviously this information here is not going to be super useful since we don't have any information about our label yet. But you can see these are just points for all the 250,000 rows in the data frame. So what we'll do now is we'll pass the label to, so we can color it by label. And so this still isn't super useful. We'll have to modify a couple things here to make sense of this. And so right now, you can see most of these points fall somewhere around 1, right? But because there are outliers where, sometimes in 4 hours, I guess the price over doubled or almost tripled in some instances between now and 2017. And so we're going to want to change this range so that it better fits our data. So a few parameters we can use here. We'll use color, continuous scale, range color, and midpoint. So we can define these things so that it kind of better fits our plot. Oops. So for our color continuous scale, this is basically the color scheme you want to use. We're going to use red, blue. There's a bunch of these you can find in the Plotly documentation, but we're going to use red, meaning the price went down, and blue, meaning the price went up. For the range color, this specifies the min and max of this color scale here. So let's use 0.97 to 1.03. We're going to look for, basically set it to a 3% increase or decrease on either side. And then our midpoint, obviously we want to be 1. Anything above 1 will get a bluish color, and anything below 1 will start on the red scale. And so let's try this again. And so I realized I actually switched the open and close price here. So for the future price that we're gathering, when we're generating our labels here, we actually want to look at the open price here. So we're going to sell at or theoretically we would sell at the open of the future hour, and we would buy at the close of the current hour. And that's important to make sure you're not using future data in your data set, obviously, because when you're actually trading live, you're not going to be able to look into the future. And so in this sense, buying at the end of the hour, we're not using any future data in our data set. And so I'll rerun this and we'll get back to the plot. And so now that that's done, we can once again refit our model and add the labels. We can delete this cell here. And now we want to plot these points by color here with respect to their principal components. And so you can see this is a very noisy plot. Most every area in here is just a mix of red and blue by the looks of it. And this is really, shows you the difficulty of trading and why trading algorithms, when used properly, can really kind of sift through this noise and pick out the good buy signals in a very noisy data set like this. If you're a day trader trading without an algorithm, you're relying on your own analysis of technical indicators to find some pocket in here where you're trading on average in a profit. And so what jumps out to me initially is we're looking for pockets of blue here. Obviously, we want our average profit to be in the blue or greater than 1. So what jumps out to me here is this area on the right side. We can actually more easily visualize this by looking at this same data but using averages for each region. So you could imagine we would take an average of little squares of or little quadrants of this, or just little corners of this data set, and we can plot the average of each of these points in that region. And so a good way to do that, I already wrote up a function. If you're interested in reading that function, I'll post a link in the description to it. But from this plot utils file, I have a function written called shade plot. And so that we'll use that to kind of visualize this a bit more clearly. And so this takes in the data frame and the X column, which is our PCA1, the Y column, which is our PCA2. And it also has a parameter called n splits and average column. So our average column is the column that we're taking the average of within each of those boxes. So our average column is going to be our label, and our n splits I'm going to set to 50. This is just defining how many regions do we want to split this into on each axis. So this is going to be a 50 by 50 grid that we're looking at. It looks like I need to add NumPy. And so I didn't have NumPy import in that file, but I just added it in, and now I can see if we run this shade plot function, you can see we get something like this. So what this is doing is it's taking, as I mentioned, breaking this up into regions and taking the average label, or the average increase or decrease within that region. So this kind of is a more digestible way to look at this big mess of this big scatter plot here. And as I mentioned, this corner over here is kind of the most interesting area in terms of the buy signal, just because almost every square here is averaging out in the positive. And so if you use this as a buy signal over the past 3 years, you would be averaging, in some cases, almost 1% per trade. And as you go further left on principal component 1, you can see it gets a little less. Near the top here, this could be a good short signal. In these cases, the price more often than not was decreasing, or the average is below 1. And so you might want to short some cryptocurrency there when the principal components are in this region. You can also look at the medians, which is kind of the same shape, but just gives you an idea if there's really big extremes in one spot that are bumping up the average and it's not really representative. So the medians, it looks to be pretty similar data set we're looking at with the medians, or plot rather. And then lastly, the counts. So this would be useful to know, yeah, this region is very blue, but there's not a lot of trades in this region, or you wouldn't have, if you use it as a buy signal, you wouldn't have a lot of trades. And so you can see, our blue region over here in this corner actually has a significant amount of trades you would have made over the course of those 3 years. And so how do you actually use this in practice? So the next video will be probably not using this strategy. Maybe we could try to implement this one. But basically, you need to be able to port that model over into, you read all the data live, you compute your technical analysis features, and then you use the model to compute principal components. After you compute those principal components, you can define some sort of cutoffs wherever you think the best buy signal is, and if it meets that cutoff, or if it falls within that region that you've previously identified based on historical data as a good buy signal, you can go ahead and buy. So how do you port that model over to a different script? There's a library called Pickle that allows you to, I have some chunks of code here that allows you to basically just save any model from, or any Python object in general actually, but you can just import pickle, and you can run this line of code here, define a file name. We can just call it PCA model. And this line of code here will allow you to save that to a file, and it'll just save in your current working directory. So I'll comment this out for now. And if I run this, you can see now in the working directory we have this file called pcamodel.pkl. So then if you ever want to use that later, like when you're actually implementing Strategy Live, you can call this load function, and you can load that based on the file name. So we can save it again and then read it back, and you can see we have our PCA model here. You can then transform whatever data you have in that future use of the model. I have back tested based on some of these strategies. I think this tends to work pretty well in terms of actually associating these with buys and sells. I mean, theoretically you could multiply the number of trades within each of these regions by the average or by their label value, and you could get a pretty good estimate of what would have happened had you used that buy signal, or you could actually go through the backtesting environment that we developed in the last 2 videos, which shouldn't be too difficult to implement. Basically just kind of combining the things from what we've done here today and what we've done in previous videos into that backtesting environment. So I think that'll wrap it up for this video. As I mentioned in the next video, we plan to actually finally implement a strategy live and send our buys and sells based on whatever strategy we decide to use. Actually send them to the Binance API and trade, maybe put some real money in there and see how it plays out over a couple weeks, or come back with a results update with that. But I hope you enjoyed this part of the series, and I'll see you in the next one.